part 2 of chapter 8. So, other methods of paleoclimatologists, dendrochronology, that's the tree ring dating. You don't have to chop down the tree to count those rings. You could just drill in and you pull out a sample that kind of looks like a pencil, and you could count those lines and do an examination. Actually, did some work with Kurt Werner, who does dendrochronology for the University of Minnesota, and had some interesting work. He's looking at mostly just Minnesota, and he's found some interesting changes through time. Also, for example, if you're looking at those tree rings, right? Well, those are growing patterns. The dark lines are winter when growing is less, and the light lines are summers when it's warm and it's growing more. And it looks like we're in a warming trend in Minnesota here from the samples that I saw. And I've heard other similar evidence. So you also have, did I mistype that? Well, you have pollen analysis dating, right? So you go to a bog, which is kind of a swampy area where you could drill down, and because there's not much oxygen in the water in a bog, these dead plant particles do not degrade, and they last a long period of time. So you could drill down and go look back in time and look at what was floating around the air, what was their composition like, do an analysis like that. I haven't done any of that myself, but it sounds like it'd be interesting. So there's a number of different causes of climate change. We'll look at a bunch of these. So eccentricity cycle, right? When we started off the class, we talked about Earth going around the sun. Well, every 100,000 years, the Earth goes out a bit further from the sun. Right? This is a long period change that happens, and you can imagine what effect that would have on climate. For example, in Minnesota here, if the winters were so cold and long that in the summer, even if it got quite warm, not all the snow melted. Well, then each year you'd be basically building a glacier. That's how glaciers happen. There's less melt off than there is, icy precipitation. Obliquity cycle. That's, again, how much the Earth is tilting on its axis. And again, this is a 41,000 year variation. And it's not a huge difference, but it's enough to, when mixed with other factors, have a significant effect on climate. Precession cycle, 21,000 years. Well, this basically determines, how close or far away we are from the sun during what season, right? So, for example, today, in January, we're a little bit closer to the sun. It doesn't make a huge amount of difference, but taken together with other things in long periods of time, it conceptually can make very big differences to our climate. For example, you could have multiple cooling trends that come together. Those effects will be magnified. Excuse me. So again, when you're looking at climate and not confusing it with weather, kind of interesting thing in the 1970s, it seemed that climate had been measurably cooling for about 20 years, and although most scientists said that at the time that, well, this isn't a long enough trend to really predict to say if the Earth is cooling or not, there's a very controversial Newsweek article that had stories about a cooling world in 1975. If you Google it, you could probably read it. And it's interesting because, now that you've been doing your discussion contributions and you've been doing a little bit of research, you'll see that, some sources are just better than others, right? If you use a source of, some guy's blog somewhere, that's not as good as maybe something done by a peer-reviewed academic journal. And by that, the Annals of the Association of American Geographers, for example. If someone wants to publish in that, their research will be studied for up to 2 years to see if there's any flaws in it. And if anyone finds flaws, it's sent back to the person who wrote it. And they say, okay, fix these flaws and we'll look at it again. And as you can imagine, that kind of document is more rigorous, although not flawless by any means, but more rigorous than something in a news article. I mean, how many times have you seen something on the news that you knew was outright wrong, right? It's happened to all of us. So it's all, it's controversial because it comes to what kind of sources are you using, how good was that source, same types of things that, students and just everyone in their daily lives encounters when they're trying to figure out what the heck's going on in the world, because you don't have the time to know everything and experience everything firsthand. So more ways that climate can be changed. Well, volcanoes. Volcanoes put a lot of stuff up in the air. And sure enough, when we've looked at, bog cores or dendrochronology or different methods of looking at what past climate has been like, when there was a large volcanic eruption, it seems that afterwards temperature will decrease for a fair amount of time depending on how big that volcano was and where it was. And this makes sense because, all that ash, well, it reflects the sun's rays, so it cools things off. And I have the question here, ever hear of nuclear winter back in the 80s? I'm not sure if any of you remember the 80s, but back in the 80s there was a lot of fear about what if there's a nuclear war, all the ash that the bombs would send in the atmosphere would blot out the sun, and we would have winter for many years. So is global warming happening, and why? Is it or isn't it happening? Well, according to our book, and in my opinion, it appears that there is warming going on. All right. Why is this happening? Well, this is very controversial. There's articles coming out all the time talking about a lot of different things, talking about, well, yes, we have had an extra long sunspot cycle recently. We've had a number of different things going on. Carbon dioxide, as we've talked about before, is a greenhouse gas. It warms Earth. So is methane and a number of different things. And, it does come out of our gas pipes. And when we burn fossil fuels, we are putting it out there. And it's also true when things like a volcano happen. Well, that'll shoot out a lot too. So there's all kinds of different ways that this stuff can get out. And once it gets out, how long would it take if you wanted to make changes for those changes to go into effect? Well, with methane, relatively quickly. But something like chlorofluorocarbon, CFCs, we talked about that before. Back in the 80s, there were laws to diminish it. And now, 20 years later, we're finding some results. Something like carbon dioxide, really long time to actually make an effect once you change some things. And to be honest, I don't know if we are going to make any changes. I've been around a long time. Well, I'll give you my 1 minute little rant since I have about a minute left here. I think that we're getting a lot of really interesting technologies that are coming around, such as using microorganisms to create petroleum. And so you would, in effect, be taking carbon out of the air for fuel. And yes, it would go back in the air, but it would be a cycle rather than just an absolute. Solar energy is getting cheaper and cheaper. I think that within the not too distant future, having a less polluting world will become very economically feasible. Until then, I just don't think there's political will out there to do much. So that's my 1 minute rant. So little ice age. How can you have little ice age? Well, in a nutshell, I'm running out of time here. Actually, let me see if there's any important aspects before I move on. I have a lot of examples of glacier size changing. Actually, you could read this on your own. Look at these photos and think about what you think, and I'm sure I'll see posts on this in the discussion section.